Good morning, students. Today we are going to learn about first shifting theorem. Yesterday we started Laplace transform. We given definition of a Laplace transform and a standard formulae, linear property, and problems on linear property. So today we are going to learn about first shifting theorem of Laplace transform. So first shifting theorem may get for 1 mark, and whereas the problem on first shifting theorem comes for 3 marks. So this is marks from the first shifting theorem in a semester and exam. So before going to the first shifting theorem, what is the important is you need to know the standard formula, the 8 standard formula that we are given in a previous class. That should be known. If you know the formulas, then only we can able to do the problems. So just recall I given what is that recall that we defined a Laplace transform, that is integral formula. It comes in terms of s, and s is a parameter, and we went for a 8 standard formulae, and after giving a 8 standard formulae we went for properties. First property, linear property, you will get for 3 marks. Statement of a linear property you may get for 1 mark, and the problem on linear property you may get for 3 marks. So we did many problems at about I think 10 problems we did with solution. I given all types of problems that comes in examination, and I already given you the homework also. So why we are doing many problems, in this COVID-19 situation you may not have a textbooks or material. That's why we are trying to do as many problems as in each topic. So now this is a recall of the last class. What is the important point to be noted is that you must remember all the 8 standard formulas. So can you can you tell me the formulas now? The 8 standard formula, I will put that to previous slide of mine, that is with 8 standard formulas. That is, this is the style standard formula. L of k is equal to k by s. L of 1 is equal to 1 by s. L of 2 is equal to 2 by s. L of 3 is equal to 3 by s. L of 10 is equal to 10 by s. L of e power of at 1 by s minus a. L of e power of minus at 1 by s plus a. Are you getting? L of e power of at, e power of plus means formula is 1 by s minus, and L of e power of minus means answer is 1 by s plus a. For plus it is minus, and for minus it is plus. And L of sin at, a by s square plus a square. L of cos at, s by s square plus a square. So for sin always a by you will get, and for cos always you will get s by. And L of sin h at, again sin a by s square minus a square. For sin at the denominator is plus, for sin h at the denominator is minus. Similarly, L of cos h at, s by s square minus a square. So cos comes, therefore numerator s, cos h at denominator plus, cos h at denominator minus. It is L of t power of n is n factorial by s power of n plus 1. So these are 8 standard formulae of Laplace transform. By using these formulas we solved many problems on linear property. So before going to first shifting theorem, I recall these formulas. So because if you don't know the formula, if you are unable to behead these formulas, then we cannot do the problems. So mathematics means you should know the formula, basic things, basic definitions, basic formulas, basic properties. If you know the things, then only these things, then only we can able to do the problems. So that's why we define a Laplace transform, that is an integral formula, integration 0 to infinity e power of minus st into f of t, denoted by L of f of t. But the integration value is in terms of s, that's why it is denoted by f bar of s, where s is any parameter. That is a definition of Laplace transform. Then we given its standard formulas. Then we went for the linearity property, and then we did the problem. So this is what we covered in the last class. Now today we are going to cover first shifting theorem and the various problems on first shifting theorem. So before that, I recall all these things, and main thing is properties. Are you able to get it? One more time I am giving. L of k is equal to k by s. L of e power of at 1 by s minus a. L of e power of minus at 1 by s plus a. So for plus you will get minus, and for plus minus you will get plus. L of e power of at and L of e power of minus at. L of sin at a by s square plus s square, whereas L of sin h at a by s square minus s square. This is sin means you will get a by, and for sin at for trigonometric denominator is plus, whereas hyperbolic trigonometric is minus. L of cos at s by s square plus s square. For cos always s by comes, and cos h at is s by s square minus s square. So you can see this for cos at and cos h at. Last one, this is L of t power of n is n factorial by s power of n plus 1. L of t power of 2 is 2 factorial by s cube. L of t power of 3, 3 factorial by s power of 4. L of t power of 10, 10 factorial by s power of 1. What is a factorial? 2 factorial means 1 into 2. 3 factorial means 1 into 2 into 3. 4 factorial means 1 into 2 into 3 into 4. 5 factorial means 1 into 2 into 3 into 4 into 5. In general, n factorial means 1 into 2 into 3 into 4 into 5 into and so on into n minus 1 into n. So that's all these things we covered in the previous class only for benefit of you. I am recalling you in first 5 minutes so that we can able to the problems on first shifting theorem will be very easy for you if you know all these standard formulas. So this is a formulae. So if you want, you can read once so that we can move on. So okay. So let us go on. So what is the first shifting theorem? So this is first shifting theorem. It comes for 3 marks. I already told you what is a first shifting theorem says. If L of f of t is f bar of s, so that is Laplace transform of function f of t is f bar of s, then L of e power of at into f of t. So if it is multiplied by e power of at, then it is f bar of s minus a. So very easy, you see. L of f of t is f bar of s. If f of t is multiplied by e power of at, then the answer is at place of s you have to write s minus a, that is f bar of s minus a. Are you getting? If L of f of t is equal to f bar of s, then L of e power of at into f of t is equal to f bar of s minus a. Similarly, if L of f of t is equal to f bar of s, if it is multiplied, f of t is multiplied by e power of minus at, then L of e power of minus at into f of t is at place of s plus a, that is f bar of s plus a. So this is our first shifting theorem. If I will repeat one more time. If L of f of t is equal to f bar of s, then L of e power of at into f of t is equal to f bar of s minus a. At place of s, you have to write s minus a if it is multiplied by e power of at plus. Here it is e power of minus at minus, then it will be plus s plus a. So for plus, s minus a, for minus, it is s plus a, same as in the formula L of e power of at 1 by s minus a, L of e power of minus at 1 by s plus a. So this is our first shifting theorem. Today's topic, you may get straight first shift theorem for 1 mark. If L of f of t is equal to f bar of s, then L of e power of at into f of t is equal to f bar of s minus a, or L of f of t is equal to f bar of s, then L of e power of minus at into f of t is equal to f bar of s plus a, just like it is. So let me erase all these things, erase this, let me put in aeroplane mode so that no disturbance comes. So what I am telling is just like product rule. What is that? E power of at into f of t, e power of minus at into f of t, Laplace transform of product of two functions, but it is not a general product rule. The first function should be e power of at or e power of minus at. So this is what it given, that is, it is a product rule of Laplace transforms, that product of two functions, but whereas the first function should be exponential, that is e power of at or e power of minus at. For e power of at at place of s, you have to write s minus a. If the first function is e power of minus at place of s, you should write s plus a. This is so general product rule is not there in a Laplace transform. Only a particular one, the product of two functions where the first function is exponential, e power of at or e power of minus at. In the coming classes we may learn product of two functions where the first function is t square, t cube, like that. That is algebraic function. And product of two functions where the first function is 1 by t or 1 by t square, 1 by t cube. Only a specific, a particular rule for product is there, the product of two functions, but the condition is the first functions may be exponential, or first function may be algebraic, or first function may be reciprocal of algebraic. Like that we have only conditional product rule, but not general product rule for Laplace transform. Whereas in differentiation we have a general product rule for differentiation, derivative of product of two functions, that is product rule we have. In integrations also, integration by parts or a Bernoulli rule is there to find integration of product of two functions, but there is no general rule to find Laplace transform of product of functions. But there are a particular cases where you can find Laplace transform of product of two functions, but the first function must be exponential, e power of at or e power of minus at, covered in first shifting theorem. In coming classes, product of two functions, the first function is algebraic, that is t square, t cube, like that, and first function may be 1 by t, 1 by t square, like that we are going to cover. So what I want to tell you is there is a no general product rule in Laplace transform, only the special cases are there. Among them, the first shifting theorem gives one special case, that product of Laplace transform of product of two functions, but whereas the first function must be e power of at or e power of minus at. If the first function is e power of at, that is L of e power of at into f of t, then at place of s you have to write s minus a, that is f bar of s minus a. If first function is e power of minus at, that is L of e power of minus at into f of t, then at place of s we will write s plus a, that is f bar of s plus a. That's it. This is our first shifting theorem. In examination we may get straight first shifting theorem. So now let us move on to the problems. This is our first shifting theorem multiplied by e power of at or e power of minus at. For e power of at you will write minus, and e power of minus at we will write plus. So let us go to the problems. So our motto is to cover many problems in the same video lesson. So what is the time left is half an hour. So for introduction we given for 15 minutes went on. So now let us, in this half an hour class, let us cover as many problems as we can. So let us straightly move on to the problems. So this is our first problem. Find L of e power of 2t into t power of 5. So it is multiplied by the first problem. It is multiplied by e power of 2t. It is plus. Plus means you have to substitute minus. So that is nothing but L of t power of 5, where s tends to s minus 2 by first shifting theorem. First shifting theorem says whenever the function is multiplied by exponential e power of at, then s replace s by s minus a, e power of minus at, then replace s by s plus a. So now here e power of 2t, so we are replacing by s in terms of s minus 2. So what is L of t power of 5? So we need to recollect the formula, the standard formula, L of t power of n. What is L of t power of n? It is n factorial by s power of n plus 1. Now instead of n we are having 5, so it is 5 factorial by s power of 6. So L of t power of 5 is 5 factorial by s power of 6. Replace s by s minus 2. What is 5 factorial? 5 factorial is 1 into 2 into 3 into 4 into 5. 1 into 2 2, 2 into 3 6, 6 into 4 24, 24 into 5 120. Therefore it is 5 factorial is 120, and replace s by s minus 2. The final answer is 120 by s minus 2 whole power of 6. 120 by s minus 2 whole power of 6. So note it down. This is using first shifting theorem. So when how to identify the problems on first shifting theorem? It should be product of two functions, and first function must be an exponential, first or second. You can replace a into b is equal to b into a, we know. So in product of two functions, one function should be exponential, then only we can do. Are able to get it? So this is problems on first shifting theorem we are doing. So note it down so that we can move on. L of e power of 2t into t power of 5. So in a product of two functions, if one function, maybe first or second, if one function is an exponential, then we can apply first shifting theorem of Laplace transforms. So now shall I go to the next problem? Find L of t into e power of 5t. Again, I said product of two functions, but first function or second function must be exponential. It should not be first, because a into b is equal to b into a. So that's why it is given t into e power of 5t. Now we are writing e power of 5t into t. I am writing exponential as a first, so that we can apply first shifting theorem. What first shifting theorem says? If a function is multiplied by e power of 80, then you have to replace s by s minus a, and if it is e power of minus 80, replace s by s plus a. Now it is e power of 5t, therefore you have to replace s by s minus 5. What is L of t? L of t power of n is equal to n factorial by s power of n plus 1. So L of t power of 1 is 1 factorial by s square. What is 1 factorial value? 1. Now replace s by s minus 5, you get 1 by s minus 5 whole square. Are you able to get it? So what is the change here? What is the change in the second problem? It is problem is t into e power of 5t. In first problem, our first function itself exponential, but here the second function is exponential. So what I want to tell you is we can apply first shifting theorem when the Laplace transform of product of functions are asked us, and among the product, whether maybe the first function or the second function must be exponential. It is not that it should be the first function exponential, maybe the first or maybe the second. If it is the first, directly you can apply first shifting. If it is the second function is exponential, then interchange them, because a into b is always equal to b into a. Commutative property is true for multiplication. Therefore you can write the exponential first, then apply first shifting theorem. So only for that variation I given this problem, because almost very similar to the first problem. Only the variation is in the first problem the exponential function is the very first function, and here the exponential function is the second. We are writing the second as a first, and then we are applying first shifting theorem. So remember the theorem, very easy. What we need here, we need to remember the theorem and we need to recall all 8 standard formulas. What the theorem says, if a function is multiplied by e power of at, then in answer you have to replace s by s minus a, and if a function is multiplied by e power of minus at, then we have to replace s by s plus a. That's all. This is our first shifting theorem and our second problem. So note it down so that we can quickly move on to the next problem. So this is our third problem. Find L of e power of minus 3t into cos 4t. So again you see, this is Laplace transform of product of two functions where the first function is one of the function. Let me put in the way one of the function, because don't confuse, it may be first or it may be second. In previous two problems we made you to clear that the product of functions in the product, if the first function is exponential or if the second function is exponential, then no need to worry, you can apply first shifting theorem. So that's what I want to clear through the problem, so that you may get a clear idea. So now what is the question is, L of e power of minus 3t into cos 4t, product of two functions in which one of them is exponential, so you can apply first shifting theorem. So which L of e power of minus 3t into, so L of e power of minus 8t into f of t, you have to replace s by s plus a. Now you have to replace s by s plus 3. So applying, that is L of cos 4t, replace s by s plus 3 by first shifting theorem. So what is the standard formula? So you see in every problem what we need a standard formula, the 8 standard formula. If you are able to remember, then only we can able to do the problem. So that's what I want to tell you. What I want to tell you is, it is very important that you should by heart all those 8 standard formulas, very repeat many times, read them, read and practice them repeatedly, so that you can able to remember them. Once you remember them, you can do the problems, the solution of problems, solving problems becomes very easy, guys. So now L of cos 40. So what formula you should recollect in your mind? The formula is L of cos 80. What is L of cos 80? L of cos 80, cos means it is s, cos 80, s by s square plus s square. If it is cos h80, then s by s square minus s square. Yes, that's good, right? Now L of cos 80, L of cos 80 means s by s square plus s square. Now cos 40 means s by s square plus 4 square. Replace s by s plus 3. You have to replace s by s plus 3. So here it is gone. You have to replace s by s plus 3, guys. So s plus 3 by s plus 3 whole square plus 4 square means 16. You have to replace s by s plus 3. Answer is s plus 3 by s square plus 6x plus 25. Are you able to get it? So this is at place of s, you have to write s plus 3. If you go to the next problem, you may get it now. You see here also. So L of e power of minus t into cos 2t, e power of minus 80. If it is multiplied by e power of minus 80, then you have to replace by s plus a. Now e power of minus t means it is L of cos 2t, replaced s by s plus 1. So what is L of cos 2t? Same formula, L of cos 80, s by s square plus s square, s by s square plus s square. So what you get? s by s square plus 2 square. 2 square means 4. At place of s you have to write s plus 1, that is s plus 1 by s plus 1 whole square plus 2 square. S plus 1 by s square plus 2s plus 1 plus 4, that is s plus 1 by s square plus 2x plus 5. So this is very similar to third problem. No change here. Very easy problem and very similar to the third problem. Are you able to get it? So third and fourth are very similar. In third problem e power of plus 80. Now fourth problem e power of minus 80. That's it. So let us move fast so that we can cover more problems. So next problem, now the same problem. Find L of e power of minus 2t into sine 4t. Again, product of two functions. Among them one is a what is the first one? Exponential. First or second, one function should be exponential so that we can apply first shifting theorem. So that is L of sine 40 where s is replaced by s plus 2 by first shifting theorem. What is L of sine 80? Sine 40 means you need to know sine 80. So in every problem we are coming across standard formulae. That is the use of standard formulas. That's why yesterday I told you many times. Today also I recalled the same. I given the same slide also. Why? Because if you know the formulas, then only you can do the problems. So what is L of sin 80, guys? L of sin 80, yes, that is a by s square plus a square. Yes, L of sin 80, sin h 80. Sin 80 means a by s square plus a square. Sin h 80 means a by s square minus a square. That is plus in denominator and minus in denominator. That's only the difference between L of sin 80 and L of sin h 80. So if you repeatedly read the standard formulas, automatically you can remember like this. Like this you can remember, guys. So L of sin 80, a by s square plus a square. Now L of sin 40, 4 by s square plus 4 square, where s tends to s plus 2. So at place of s you have to substitute s plus 2. So 4 square is equal to 16. Therefore 4 by s plus 2 whole square plus 16a plus b whole square. S square plus 2ab plus b square, that is s square plus 4s plus 4. So final answer is 4 by s square plus 4s plus 20. 4 by s square plus 4s plus 20. Are you able to get it? So I will take out all this, and now you can see s. So this is a fifth problem. So let us go to the sixth problem. What is that? L of e power of 3t into sin h 40 now. Sin h 40 now. So are you able to recall what you identify the problem? You see it is a product of two functions and among one of them is exponential. So straightforwardly you have to apply first shifting theorem, and e power of 80. E power of 80 means s replaced by s minus a. Now L of e power of 3t you are having s replaced by s minus 3. So this is L of sin h 40 replace s by s minus 3. Now in what we are coming, first problem L of t power of n formula. In second in other problems you have got L of cos 80, now sin L of sin 80, now L of sin h 80. So what is the formula? Recollect in your mind. What is the formula now? L of sin h 80. L of sin h 80 is a by s square minus s square. L of sin h 80 is a by s square minus s square. Are you able to get it? A by s square minus s square. Now L of sin h 40. Sin h 40 means 4 by s square minus 4 square. Replace s by s minus 3. What will you get? 4 by s minus 3 whole square minus 4 square. What is 4 square? It is 16. 4 by s minus 3 whole square minus 16. So this is our answer. And if you want, you can write a minus b whole square. What is a minus b whole square? A square minus 2ab plus b square. Here it becomes s square minus 6x plus 9 and minus 16. So that gives answer. So this is our final answer. So L of e power of 3t into sin h 40. L of e power of 3t into sin h 40. So we are coming across all standard formulas you see in the problems, what you are getting, L of t power of n we got, L of cos at we got, L of sin at we got, L of sin h4t you are getting. So all type of problems, all type of standard formulas, all standard formulas we are using here. So that is the case, we have to remember all formulas, then only, and read the properties, then only go for the problems. So this is the sixth problem we covered. Now let us try to cover more number of problems. What is the time left? Can anybody tell? Yes, 20 minutes more. We covered 20 minutes and another 20 minutes to go. So let us move on. Yes, this is a problem. What is that? Find L of e power of minus 3t into 2 cos phi t minus 3 sin phi t. So again, product of two functions. First one is e power of minus 3t and second one has two terms here. 2 cos phi t minus 3 sin phi t. Don't confuse, very easy, very similar to that. Only it looking a big but very, very simple. No need to divide, no need to separate, directly you can apply. So it is multiplied by e power of minus 3t. So s is replaced by s plus 3. That is our first shifting theorem. What it says, if e power of 8 into f of t, then replace s by s minus a. E power of 8 into e power of minus 8 into f of t, then replace s by s minus a. Now it is multiplied by e power of minus 3t. Therefore replace s by s plus 3. That is L of 2 cos phi t minus 3 sin phi t, replace s by s plus 3. This is our first step. Now what you are having, you can apply now linearity property. What linearity property says? If a function is multiplied by a constant, that constant can be taken outside. We seen the same thing in differentiation. Different derivative of constant multiple of function means constant outside the derivative of function. We seen in the same in integration also. Whenever we are finding integration of constant multiple of a function, we can take constant outside of integration. Here also by linearity property, in a linearity property of Laplace transform says that whenever you are finding Laplace transform of scalar multiple of a function, that is a function is multiplied by a constant, then you can take that constant outside and apply Laplace transform for only function. Are able to get it? So we did the same thing in differentiation, integration and Laplace transform. The same thing we are applying here. So take the constant outside, apply the Laplace transform only on functions. That is our linearity property. So we are using the two properties in the same problem. What is the first one? First one we are using for shifting theorem, and the secondly we are using linearity property. So that's why such a problems we are testing for standard formulae. It is a test for linearity property. It is also test for first shifting theorem. That's why many things are tested in the same problem. So such a problems have a more scope to come in examination, and this is a previous question for 3 marks. Are able to get it? So 2 constant outside L of cos phi t minus 3 constant outside L of sin phi t. You can recollect the problem formulae. What is that? L of cos a t s by s square plus phi square s square. Now L of cos phi t s by s square plus phi square. L of sin a t s by a by s square plus s square. Now L of sin phi t phi by s square plus phi square. That's it. Now replace s by s plus 3, 2 into s plus 3 by s plus 3 whole square plus 25 minus 3 into 5, 15, 15 by s plus 3 whole square plus 25. So this is our answer. 2 into s plus 3 by s plus 3 whole square plus 25 minus 15 into s plus 3 whole square plus 25. So this is the problem we covered. This mostly it is repeatedly many times came in examination for 3 marks. So don't confuse, only simple. So first read what is a linearity property, and read what is a first shifting theorem, and read all standard formulae. Then attempt practice these problems so that you can gain the knowledge on this concept. Are able to get it? So this is 7 problems we covered. Is time permits, let us go to more problems, guys. Yes, another 10 to 15 minutes are there, so that we can go to the next problem. L of, find L of e power of minus t into cos square t. So it is very easy to identify the problem. If you are asked to find product of two functions, if you are asked to find product of two functions, Laplace transform of product of two functions, in which one of them, I saying one of them, not the first one, in which one of them is exponential, then you can apply first shifting theorem. So now you see what is the problem here. The problem is L of e power of minus t into cos squared t. L of e power of minus t into cos squared t. It is product of two functions and the first one is e power of minus t. Then you can apply first shifting theorem. What first shifting theorem says? L of e power of minus at into f of t. If it is a minus, you have to replace it by s by s plus a. Now it is multiplied by e power of minus t. Therefore replace s by s plus 1. That is L of cos square t, where s is replaced by s plus 1. Are you able to get it? What is L of cos square t? L of cos square t. There is no, yes, right. There is no direct formula for L of cos square t. We have a formula for L of sin a t, that is a by s square plus a square, and we have a formula for L of cos a t, that is s by s square plus a square. But we don't have the formula for L of cos square t. L of cos square we didn't have in a previous, in linearity property problems also we did this L of sin square and L of cos square. If it is a sin square, we can sin square a is equal to 1 minus cos 2a by 2, and cos square a is equal to 1 plus cos 2a by 2. Are you getting? So at place of cos square we are writing 1 plus cos 2a 2t by 2, 1 by 2 constant outside by using linearity property. Are able to get it? So seventh problem and eighth problem, what we are doing? We are applying first shifting theorem and we are applying the linearity property. Here we are using cos square a formula. What is cos square a? 1 plus cos 2a by 2, and we are using standard formula. So many things we are using in the single problem. That's why such a problem comes in examination for 3 marks. So this is a previous question for 3 marks. Are you able to get it? Why the problem coming in the examination? We are applying firstly first shifting theorem, secondly the formula cos square a formula, thirdly we are using linearity property, and fourth one we are using standard functions. So many things we are using, so much of knowledge is tested in a single problem. That's why these kind of problems comes in examination. So see, 1 by 2 is a constant outside L of 1 plus cos 2t. That is 1 by 2 outside L of 1 plus L of cos 2t. What is L of 1? L of k is k by s. You have to recollect the formula immediately whenever you come across this particular problem. So you have to apply the standard formula. So remember the formulas and analyze where they can come, where they can use it. So L of k is equal to k by s, L of 10 is equal to 10 by s, L of 5 is equal to 5 by s, L of 1 is equal to 1 by s, and L of cos 2t. Now recollect again the formula, standard formula. L of cos at, L of cos at is s by s square plus s square, s by s square plus s square. Now L of cos 2t is s by s square plus 2 square. 2 square means 4. So what is next step is 1 by 2 into L of 1 1 by s plus L of cos 2t s by s square plus 4. So replace s by s plus 1, replace s by s plus 1. So the final answer is 1 by 2 into 1 by s plus 1 plus s plus 1 by s plus 1 all square plus 4. Are you able to get it? So that's what I said, why these problems coming many number of times in examination. First one we applied first shifting theorem, second one we are used cos square a formula, cos square a is equal to 1 plus cos 2t by 2, and third one constants taking outside means you are applying linearity property, and then you are using standard formula of L of 1, that is 1 by s, L of cos at s by s square plus s square. So these many things we are used in a single problem. That's why it is coming for 3 marks in examination. So this is the 8th problem we covered. Let us move on to the next problem. So find L of e power of 4t into sine 2t into cos t. Cos t, it is cos t. E power of 4t into sine 2t into cos t. It is product of 3 functions, you may say, but here idea is e power of 4t is a one function and sine 2t cos t is the other function, product of 2 functions. Among them one is exponential, that is e power of 40. E power of, if it is multiplied by e power of 80, then replace s by s minus a. That is our first shifting theorem. Now it is multiplied by e power of 40, therefore replace s by s minus 4 by first shifting theorem. Now what you are having, L of sine 2t into cos t, sin a into cos b, but the formula is we are having 2 sin a cos b, so multiply and divide with 2. 1 by 2 into L of 2 sin 2t cos t. What is the formula? L of 2 sin a cos b. 2 sin a cos b is sin a plus b plus sin a minus b. 2 sin a cos b is sin a plus b plus sin a minus b. What is a? A here is 2t and b here is t. 2t plus t, 3t, 2t minus t sin t. So what is that? L of sin 3t plus sin t. You have to use the formula. Which formula again? L of sin 80. What is L of sin 80? L of sin 80 is a by s square plus s square. L of sin 3t, 3 by s square plus 3 square. L of sin t, 1 by s square plus 1 square, where 3 square is 9, 1 square is 1. Replace s by s minus 4. What is the final answer is 1 by 2 into 3 by s minus 4 whole square plus 9 plus 1 by s minus 4 whole square plus 1 at place of s. We are writing s minus 4. That is our answer. This is also repeatedly came in examination because we are using first shifting, we are using linear property, we are using the formula, the trigonometric identity 2 sin a cos b is equal to sin a plus b plus sin a minus b, and we are using the standard formula of L of sin 80, a by s square plus s square. So all these are previous questions for 3 marks in examination. But from first shifting theorem, you get a problem for 3 marks. So for 1 mark he may ask straight first shifting theorem. For 3 marks he may give so problems like this. So 9 problems we covered. Let us see, is there any time to cover any other problem. So time is another only 5 to 6 minutes we need there. So let us try to cover one more here. So this problem, this kind of problem, 9th one, L of e power of 40 into sin 2t into cos t. This is a problem many times came in examination. So time permit us. So let us take, now time is left. How much time is left? Another 5 minutes. So let us cover one problem in same type. Almost all types of problem we covered. Now let us give one more problem of same type, because these type problems are coming in examination many times repeatedly. So I am giving the 10th one. L of e power of 12t into sin 5t into sin cos 7t. Same, only just the change in the formula, that's it. Everything is same. Now it is multiplied by e power of 12t, that is multiplied by e power of 80. If it is multiplied by e power of 80, replace s by s minus a. Now replace s by s minus 12 by first shifting theorem. So replace s by s minus 12 sin 80 into cos pt, sin a into cos b, sin 5t into cos 70, sin a into cos b, multiply and divide with 2. Multiply and divide with 2. 1 by 2 into L of 2 sin a cos b, 2 sin a cos b. But sin 5t and cos 70, cos term is more. So first of all I am writing 2 cos a sin b. A into b is equal to b into a. So only for our convenient purpose, for simplicity, I am writing cos term first and sin term second, because cos we are having 70 and for sin we are having only 5t. So what is now L of 2 cos 70 into sin 5t. Now the formula is 2 cos a sin b. What is the formula of 2 cos a sin b? That is sin a plus b minus sin a minus b. What is a here? 70. What is b here? 5t. A plus b is 12t. A minus b is 2t. Are you getting here? Yes. excuse me, that is L of sine 12t minus sine 2t, where s is replaced by s minus 2. What is L of sine at? L of sine at is a by s square plus a square. L of sin 80, the standard formula. You should recollect the standard formulas. Every problem you will find standard formulas. So you have to buy out standard formulas. What is L of sin 80? L of sin 80 is a by s square a plus s square. Now L of sin 12t, 12 by s square plus 12 square, and L of sin 2t, sin 2t is 2 by s square plus 2 square. So what is our, replace s by s minus 12. So the final answer is, what is the final answer? 1 by 2 into 12 by s minus 12 whole square plus 144 12 square minus 2 by s minus 12 whole square plus 2 square is 4. So this is our answer. So this is the 10th problem we covered in this video lesson. So all these 10 problems are previous questions for 3 marks. So almost all types of problems we covered on first shifting theorem. If any problems comes in examination, you can do by using this, practicing all these types of problems. So 9th and 10th very similar, but the only formula there you are using 2 sin a cos b. Here you are using 2 cos a sin b. Like that you are having 2 cos a cos b formula, cos a plus b plus cos a minus b, and minus 2 sin a sin b formula, that is cos a plus b minus cos a minus b. So all those formulas which convert the products into additions, sums, transformation of products into sums in trigonometry. We learn the making use of those formulas, and first shifting theorem, linearity property, we are able to do these problems, and by remembering standard formula. So these are the things that you have to remember. What is that? What is a Laplace transform? What is the definition of a Laplace transform? How it is notated? And it is in terms of s, and that's why it is denoted by a power of s, and s is a parameter. That is the first thing. Secondly, you have to remember standard formula, that 8 standard formula of Laplace transform. Then we covered the first theorem, that is linearity property. What linearity property says, if it is a function is multiplied by a constant, that constant can be taken outside by Laplace transform. That is our linearity property, and we did many problems on linearity property in a previous class. And this class, what we did in this class, we given you what is a first theorem, first shifting theorem of Laplace transform. What basically it says, it gives an answer to the question that it gives is the product of Laplace transform of product of functions exist. As it exists, it gives answer for that, but it's only the one case. What is that? First shifting theorem says, if a product of functions, for a product of functions, Laplace transform can be find by first shifting theorem, but only one case. What is this one case? Is a special case, that one of them among the product, one of the function must be an exponential. If it is e power of 80, that is e power of plus 80, e power of 80, then replace s by s minus a, and if one of the function is e power of minus 80, then replace s by s plus a. So that is what it gives, is product of functions, Laplace transform of product of functions can be found. There is no general formula, but only special cases. The first special case given by the first shifting theorem, that is one of the function among the product, one of the function should be exponential function, either e power of 80 or e power of minus 80. Are able to get it, guys? We are able to solve at about 10 problems in this video lesson. So now let me give you homework. Don't worry, I am going to give only a couple of problems for homework. So before doing homework, what I am suggesting you, my advice is, read standard formulae, read first shifting theorem, already given in this video lesson. Very firstly I given you the standard formula again, not only in previous class, in this class also we put a slide for standard formulae. So read those standard formulae, by heart them, and then read first shifting theorem, what the first shifting theorem exactly saying. So read it, understand it, then attempt the problems. Identify the problem is important. L of product of two functions, where one of the function is exponential, then apply first shifting theorem, e power of 80 or e power of minus 80. If it is e power of 80, replace s by s minus a, and if it is e power of minus 80, replace s by s plus a. So after reading, after practicing, to go for these homework problems. So these are the homework problems. First one, L of e power of minus 3t into t cube. So we are using L of t power of n formula. In second problem, L of e power of 2t into cos 3t. We are using L of cos a t formula. L of e power of minus 3t into cos 5t into cos 2t, 2 cos a cos p, cos a plus p plus cos a minus p. So solve, practice all 10 problems and then try to do homework. So for any queries, you can mail me at naresh.debate@gmail.com, or you can post me in Google Classroom. And so do the homework and submit in Google Classroom so that I can verify and respond for you for your homework. So that's all for this class, guys. See you tomorrow. See you. Thank you very much. Stay home, stay safe, stay healthy. Thank you. Bye. See you tomorrow.